Good morning, students. Kalai Vanakkam, everybody. We'll wait for 10 more minutes. Let others join the session, then we'll start the session. Okay? Good morning, students. Okay, so few of you have some doubts. Ma'am, level 3 ask payment for certification. What can we do? May I know like what level 3 it is? I didn't get you, Devendran. And Dharani Priya, you can ask your doubt. Kirti, whatever doubts you have, you can just post it, guys. Post it here so that we can rectify. We will be discussing with the team and we'll let you know. Okay. Kirti, it's theory session, guys, not practical. It's not practical. So yesterday you already had a practical session. Hope you understood that. Hope you have already worked, like practiced along with us. So if you have any queries, you can just post it in Q&A section, guys. So in last class, what we have learned in the last class. Not yesterday, not, I'm asking about theory class. What all topics we have covered in that? Yeah, theory class. I'm asking about theory class. What we have covered in the last theory class. Agentic life cycle. Kirti, yeah, you can post it if you have any doubts in practical session, you can post it. So we'll solve that. Agentic lifecycle, Crew AI. And because we didn't attend any practical session. Prompt engineering. Kirti, wherever you are asking, like you're texting, right? In Q&A section, the same place you can post your query. I can see whatever you post here in Q&A section. Okay. Yeah. Okay. Yes, guys, we have learned about Agentic AI lifecycle, Crew AI features, autonomous agent, and prompt engineering. Okay, we have already also learned about uh, tools used in open system and types of agent memory, like short-term memory, long-term memory also we have learned, right? Kirti, yeah, whatever doubt you are, like you have, post it wherever you are typing all these messages in the same way you post. Practical session, like we had already completed 2 practical sessions. Okay. On the first practical session, we explained how to do text generation using Hugging Face model. Okay, we just created a small chatbot kind of thing, and we showed you how to use Hugging Face, how to use Granite models in that, and how to integrate. Okay, in similar way, in yesterday's session, we told you how, like, image to text generation. Okay, so if you like, if you have missed the sessions, you it's already live in YouTube. You can just follow the recording sessions from there, and you can learn. Okay, don't worry, you can learn from the recording sessions also. It's very clear. uh, all the practicals and the theory sessions you can follow from there. No problem, Kirti. We told from scratch. Actually, we have explained how to use Hugging Face, how to integrate everything from scratch. Okay, so you can follow that. If you want, I'll share you the live link where you can see the recording sessions from there. Yeah, yeah. This is the YouTube live link. You can just see all the recording sessions from there. Okay, so you can follow the steps what we have explained. Yesterday we had a team from trial head, so hope they have cleared all the doubts about trial head and agent force related doubts. Okay, yeah, now we'll start the session. In today's session, we're gonna learn about agents communication protocols. Till now, we saw what the agent is and how it works alone and how multi-agents work together. Right? Now we imagine how multi-agent interact and coordinate with each other, the communication between them and the protocols they follow. So we'll see now how agents actually communicate and follow all the protocols, and like all the rules for of conversations of AI agents. Okay. So what are multi-agent systems? We have already discussed this topic before. Multi-agents, that means multiple independent agents working together. Multiple agents working together. Independent agents working together is called multi-agent system. So each agent has its own goal. Okay, so for example, if we have 5 different agents, that means we have 5 different independent goals. Okay, goals, skills, and decision, everything, we have 5 different goals and 5 different skills. Okay, so we are collaborating that particular agents together and completing the task. Based on the task, we are picking up the agents which are suitable for the task to complete, and then we are collaborating with them and completing the problems, completing the task successfully. This is how the multi-agents work. Okay, so the real examples I can tell, like Swiggy, Zomato, stock market, all these are the real world examples where we regularly see. So for example, in Swiggy and Zomato, we order, okay, we order some food. So it will go to the order agent, and then goes to restaurant agent and delivery agent, then payment agent. So this is how the process happen. It's not like directly to the restaurant agent and directly from there to Swiggy agent. No, there will be some process to be followed. Search, select for the food, and you can make like add to cart, and then select the address, like payment, and everything. So you have to follow some steps to order some food, right? So similarly here also, we are collaborating with multiple agents and we are working together. That is called multi-agent systems. Is it clear? You want me to reply? This Priyadarshini, you want me to repeat or what? And Kirti, I have already shared you the YouTube link. I'm sharing you the YouTube link. You can follow that. Is it clear, guys? Multi-agent systems. Yes. Okay. Now we'll see why we generally use these multi-agent systems. Why? Because we will have many like big problems, big tasks to be done dynamically. Instead of one powerful agent, we are using like multi agents for that to solve the solution, to solve the task easily. Okay, like multi-agent systems gives scalabilities, robustness, and parallel work. The work will happen parallelly, and later it will collaborate. So the work get completed fastly. So at that time, multi-agents are very helpful. When we had a huge task to be completed with near deadlines, at that time, deadline is very important. So the only option we will have is to complete the task fast. and meet the deadline. Before the deadline itself, we have to complete the task, right? So multi agents help because the parallel work happens, and all the agents will not work on the same goal. So all the agents will have their own goals and we'll club it together by end of the task and we will finish it. That is how these multi agents actually work. For example, traffic control system. So we will have multiple traffic signals in our areas, right? So every signal is an agent. If you observe anytime, if you are in a one route, okay, from one area to other area, there are 5 different traffic signal, like 5 locations where you have traffic signals. You have to cross those 5 traffic signals and reach the destination. Okay, if one signal fails, others will work, right? If the first signal is failed, will other 4 signals stop? No, right? It will work. They will work. So that's not the issue actually. if second signal is failed, first signal is clear, second signal is failed, what about the third, fourth and fifth? They will work their work. So they are not related to this particular signal, right, which is facing difficulties. City does not collapse because of one failure. Like all other 4 are working, only one is not working. We'll go solve it and clear it, that's it, right? If we have only one agent which is giving a lot of troubles, at that time we will face difficulties. But we have 4 other agents which are working parallelly. Only one agent is not working properly, we will just go to that one agent and we will solve the issue and we'll come back, that's it. This is why we use multi-agent systems. Clear? Guys, I'm repeating again. If you have any doubts about Agent Force, champions, trial head, everything. So this session is about Agentic AI. Okay. So if you have any queries, whenever we have a practical session, at that time, team will be there which are related to trial head and all these things, champions. So they'll be clearing all your doubts. So please wait until then. Give me a minute. I'll just tell you when. Yeah, tomorrow itself. So wait until tomorrow. In tomorrow's session, the team from trial head, agent force and champions, everything, all the questions related to that will be cleared. And tomorrow is the practical session also. So please do join tomorrow's session, listen to the practical and clear all your doubts. Clear? So now please focus on the Agentic AI session. Whatever doubts you are having about other things like trial head, champions, agent force, everything. So tomorrow, all the queries will be cleared. So until tomorrow's session, please wait and focus on the session what I am telling. Okay. Tomorrow session timing is 2 to 3. 2 to 3, Tulsi. Okay. Yeah. So why, ma'am? Link, ma'am. Guys, everything will be shared to you. And Muhammad, that is what I am telling. Please focus on the session, what's happening now. Wait until tomorrow. tomorrow the team will be coming, like team will be joining in the session and solving all your details related to trial head, certifications, everything. Okay. Yeah, hope it's clear now. So like we are not the team from trial head and all these things. We are the team from Agentic AI. So please wait until tomorrow and clear all the doubts tomorrow. Okay. Please do, whoever have doubts, and please do join the session tomorrow and ask. Okay. Hope it's clear and you'll be focusing on the session, what's happening now. It's 2 to 3, Priyadarshini. It's 2 to 3 tomorrow. Yeah. Yeah. Now focus on the session, what's happening, like Agentic AI developer. Okay. Yeah. Did you understand what is multi-agent systems and why we use these multi-agent systems? Praveena, yes, all the sessions are very important to attend, first of all. And related the query what you have, like Agent Blazer champion project work, what you have, what you are doing. So whatever queries you have, please wait until tomorrow. The team related to that will join tomorrow's session. So hope you understand. We are not the team from that particular thing. Okay. And Rajeshwari, if you have entered incorrect one, please do contact your college faculty. So Rudrani, tomorrow is a practical session. If you don't have any queries also, you have to learn the practical, how to do, how to build chatbots and all, right? Using an agent. So yeah. Kritika, you didn't understand about multi-agent system? Okay. See, I'll tell you in a simple example. You are doing a project. Okay, it's a group project of 5. In your project, you are a team of 5. So we'll all 5 work on one all, like end of the day, all 5 will have one single goal, is completing the project. So before that, everybody, all 5 will work on the same work, like 5 people on coding, 5 people on front end, 5 people on research, 5 people on documentation. No, right? So all 5 will distribute some work and they will have their own separate goals. For example, if somebody is working on front end, if one people is working on front end, so that person goal is to complete the front end. And if somebody is working on the documentation, the goal is to complete the documentation. And somebody is working on the coding part, the core project part, the main goal of him is completing that particular core project, right? So all 5 will have their own set of goals. Like when you separate the task, when you distribute the task, you will have 5 separate goals. By end of the goals, you will club all 5 goals and make it as a complete project. By end of all the works, your goal will be successful, like you will complete your project successfully. And for example, if the people who is working on the coding part, or a back end one or front end one, if somebody have any errors, will others stop working? No, right? Others will do their work, and these people who are facing difficulties and who are facing the errors, they will work on that. Okay, if you complete your work, and if you complete your work, you'll go to the error and you'll check. Okay, if somebody is facing error, you'll not stop working. You'll work your work. If you complete it, you'll go to the person who is facing error and you'll solve it. Right? This is called multi-agent, like multiple people working together to solve one goal. Okay. Similarly, here also, if you have any one big task, different agents, multiple agents work together and complete that particular huge task. Okay. Until it's already live in YouTube, whoever is not able to join here, they can join through YouTube. They can see using YouTube. And this is the link for the YouTube. Okay. Yeah. Ask them to join through YouTube. Yeah. Hope Kritika, it's clear for you. Okay. Now we'll see designing multi-agent system. Like, how do you actually define it? How do you design your multi-agent systems? Like one agent, like define agent roles and decide how agents actually talk. Okay, actually communication systems, and choose coordination strategies, and handle the conflicts and failures. So based on these terms, you will design the system. Okay. For example, we your college is organizing an event. Okay, so one will be the planner agent and finance agent who is handling all the amount and all. uh, Logistic agent, like who is handling all the things properly, like food, stage and all. And marketing agent for the promotions. Right, we will, like, it's a teamwork. It's not a single people who can handle all these things, right? So this is how you divide the work. This is how you will plan before starting the event. Before scheduling the event, you will plan and then schedule. Similarly here also, see, as I told you, if your college is uh, college is conducting some event, like we had 4 different agents now: planner, finance, logistic and marketing. Right? So planner, what planner will do? He will schedule everything. When will be the guest entry, when will be the welcome dance, when will be the food, like lunch and everything. So everything will be planned by the planner agent. And finance agent, so this particular agent will look into all the budgets. Logistic agent like stage, lights, food, chairs, everything is taken care by logistic agent. And marketing, like social media promotions, making some posters, Instagram promotions, all these things are done by marketing agent. So uh, if these many people works, one event gets successful, definitely. So based on these particular things, like defining the role and the responsibilities and the communication systems, coordination strategies, how to coordinate, how to do, like how to handle the conflicts, if you have any disturbances in between, how to solve that. So based on these terms, you will design your multi-agent system. Okay. Okay, based on this, you will solve, like you will design your system before working on the task directly. Is it clear? Yes. Yes or no, guys? Like, how do you design multi-agent systems? Okay. Now we'll see like agent communication. So now we'll see how agents share information, share goals, plans, so that they can behave like a team. Okay. So share, if you share some information together, so they'll behave like a team. So exchange information and intent. Agents don't just send the data. So along with the data, they send why they are doing this, why they are sending this data. So along with the data, they'll also give some information why they are sending this particular data to this for you. Okay, like for example, in a software team, you had a software developer team. Your team lead will not just tell write a code. Will you understand? No, right? So they should say like write a logic code because we are launching a particular product in a month. So for that project, write a code. Okay, he will be very clear but why he is asking you to write a code. Okay, similarly here also, whenever the agent is sending some data to one other agent, it will tell why that particular data is sent to you. Okay, this is how the exchanges of information happen. And direct communication, peer-to-peer messaging, like agents talk directly to each other. Okay, they will talk directly to each other. For example, two delivery agents we have, agent A and agent B. So road A is blocked, for example. What he will tell? Okay, I will try to enroute it. So this so agent A is telling the road is blocked. So now agent B will try to go in some other route to reach the goal. Okay, this is how two agents communicate together and solve the issue, solve the task, complete the task. Okay, no, nobody others, like the team lead is involved here. So that happens in a direct chat itself, in between, like WhatsApp chats where we talk to our teammates. Okay, so similarly these agents talk, communicate each other and solve the issues, solve the task. So it will not go to higher people who is managing the task. So this happens in between only, internal communication happens and solve. Mediated communication. So these agents communicate through shared systems. Okay, like they can share their memories, messages, and the databases. Everything can be shared. Okay, for example, you Google Docs. We had a Google Docs. Whatever you're writing in that and giving a permission, like access to some other people in your team. So whatever changes you write in, whatever changes you make in the Google Docs, everything they can see, right? Everything they can see. Similarly, here also, they'll be working as a shared system, like Google Docs itself. One agent will update something, and the other three can see and collaborate, like coordinate accordingly and work. Enable coordination and cooperation. That means the word itself telling the coordination and the cooperation will be there. If some agent is facing any trouble, the other agents go and help. Okay. And two agents will not complete two agents will not write the same report, or two agents will not work on the same particular goal. So all different agents work on different tasks. By end of the different task, we will club everything and make one single task successful. This is the main goal of multi-agent. Okay, using the communication and the coordination, one agent, for example, I'm telling just an example. For example, you have to write an assessment, a huge assessment report. Okay, and we have 3 people who are writing on it. So everybody will write from the beginning? No, right? Some people will write the starting part, and some people will write very important points to be covered, and some people will write kind of a conclusion. So this is how they share their things, and they'll communicate in between. If somebody is facing difficulties to write, what you'll do, you'll help them, and you will help them and make it completed, right? So similarly here also, like one agent works on writing, one agent works on reviewing the details what happened, and one agent submit it. So this is how the communication happens between the agents and work together. Okay, is it clear? Is it clear, guys? Yeah, guys, I can still see some queries. Whoever entered their non-Moodle one ID wrong, or facing anything related to that particular thing, Epic ID or non-Moodle one ID, everything. So go talk to your faculty and solve that issue. Okay. So talk to your faculty, guys, for these non-Moodle one IDs related queries. Okay. So in that form, you can edit it. And again, I can see some queries related to Salesforce, Agentforce and all. So wait until tomorrow. The people who have queries, wait until tomorrow. Okay. The team related to that Salesforce team will be joining in tomorrow session 2 to 3. So they will solve everything. So until then, wait. Okay. Now focus on the session. Is it clear? Second. Okay, guys. Now we'll see the next topic. Speech act theory. So communication is not just a message, guys. So communication it's not a message. It's an action. Okay. So it can be in an action, not only the message. Like when humans speak, human can give some information, some request, and some propose, you are asking, like suggesting some plan or an idea, and confirming something. So based on the actions also, the communication happens, right? So information is like sharing some knowledge on facts, sharing some knowledge to the other people. And request, asking something, asking another agent to act, asking some help. And propose is suggesting some ideas, suggesting some plan to be followed, everything. And confirm is like taking some confirmation, taking an acknowledgement. Okay. So for example, if your manager if your manager says, please finish this by tomorrow, it's a request. Okay, it's a request, right? So next is like client approved the design. So what does it mean? What does this act call? Inform, request, propose, or confirm. Client approved the design. Your manager is telling that your some client approved the design what you have sent. What it is, guys? It's a inform, it's a inform or request or propose or confirm. That means he is informing you. He's telling you that client approved the design. Okay. And the other thing manager says is, can we change the deadline? It's a propose. Okay. And all the works are done. This is like getting some acknowledgement. He's confirming everything is done or not. This is how the act theory actually work. Not only the messages, the actions also work in the agents. Hope everybody is focusing on the session what I'm telling, because I can see the queries related to different, like based on the non-model one IDs and all. So please focus on the session, guys. Okay. Is it clear? Can I get the response? Okay. Now, agent communication language, ACL. It gives, this agent communication language gives a standard format for agent messages. Okay. These, they will be following some standard format. Okay. Standard format to be followed by the agent. So different agents can understand each other. For example, you are a front-end developer, and whenever you're talking something to your back-end developer, you should understand, right? So you will be following some format to be to understand what other agent is telling. That is the reason we will follow one standardized format. Agents follow one standardized format to understand, to like, so that the other agents understand each other. So even the agent is built by like his agent is related to some other field. If you follow this format, they can understand, as it's very clear. If you on the in the image, you can see the information like inform. It's a request, and the request what this particular agent is requesting, and so that the other agent also will understand what this agent is informing and requesting to do. It's very clear, right? So These agent communication languages defines message type, what type of messages it is sending, and sender and receiver, content and intent. Everything will be in a clear format, in a proper format, in a standardized format clearly. For example, phone call. So you will have a caller ID, receiver ID also, and the call, how much time the call you have attended, whether it's a missed call or you were talking to the person for 10 to 20 minutes or what. So these things will be same to other side people also, like everybody can understand. Okay, like if two people are in a call, other than two people, if a third person see that call also, he will understand. So they have been talking for last half an hour, so the call is from person A to person C with person B. So everybody can understand that. In a similar way, this agent communication language also happen, like without any protocol, without any confusion. So if you have some protocols and all, in between confusion happens, right? So no all the agents understand that protocols. Only few people who are related to that particular protocol only will understand what's happening. So others, they will not, as they don't have that knowledge. Okay, like, so at that time you will have uh, confusion. Okay, for example, like protocol, if we follow proper protocol, proper format, at that time we will have a clear, clean communication between the agents. So this is the structure of messaging, like agent communication language. This is the structure. Like performative is like intending of a message, what sender is asking or what sender is informing, what sender is requesting, and all will be in performative. Okay, and sender and receiver's IDs, like who is sending, for whom this message is sending. So everything will be mentioned clearly. And content is like asking, like what is the task, what is the data, like actual information will be present in the content. And optional tech context and conversation idea. This means like keep track. Okay, keep track on ongoing conversation, whatever ongoing conversations are there, there will be following one a track. Okay, so everything can be seen properly. Who is talking to whom, which conversation, like which agent ID is talking to which agent ID. So based on that, we can understand who is talking what and who had a issue, who is solving that. If nobody is solving, some other agent will come and solve that. Clear? For example, email. So whenever you are sending any email, you will be entering your detail, like your email and to whom you are writing and what will be the subject line. Okay, and the message also, message, like whatever message you wanted to post in that, send in that mail to the person, you'll write everything, and you will send. So you will follow one structure for email, right? So that the other person will understand. So similarly here also, this agent communication language will follow some instructions, like one format to be followed for messaging. Clear? Is it clear, guys? The agent communication language. If yes, we'll take a break for 10 minutes and we'll resume the session at 11:10. Okay? What is optional context and conversation ID? Kritika, like optional content is like extra data, extra background information, giving like which includes to inform the agent to understand the background information, what's actually happening. Okay, is called context, optional contexts, just to make the other agent understand. Okay, and conversation ID is like yeah, ID to identify which agent is telling the other agent to about this. It's an ID, conversation ID, the agent ID. It is okay. Like if we have multiple agents, we will not understand like which agent is telling what. So if you have an ID, at that time we will understand like which agent is talking to whom, which two agents are communicating. So we will understand, right? If we have an ID, that is just a conversation ID. Okay. And ACL full form is Agentic Communication Language. Okay. This is Agentic Communication Language, ACL is. Okay. Clear? Yeah. Okay, guys. Take a break for 10 minutes. It's already 11:03. So come back at 11:15. We will resume the session at 11:15. Okay. Okay. Shall we resume the session, guys? What is cyber forensics? So, Aditya, it's kind of a collecting, analyzing some evidence for investigation purposes they'll be using. Okay. Which is helpful for security incidents. Okay. Yeah. Now we'll see the message structure is done. So A to A protocol, that means agent to agent communication. How that happens? So agent to agent protocol, like it's kind of a communicating one agent to the other agent between intelligence agents. Okay, messaging, talking, like it's just kind of rule book, like how to talk, to whom to talk, and what format you have to use whenever you're communicating between the agents. So following all the rules, like rules and all, you have to communicate. So whenever the agent is communicating to other agent, all the rules should be followed, like how you have to communicate, how to talk to the other agents directly, and how to, like, to whom to talk, and in what format one agent should communicate to the other agent. So all these are like the rules to be followed when the agent is communicating with the other agent, just like humans. So whenever you are talking, like everyone here from Tamil Nadu, right? So whenever you are talking to your friends or to your family, you'll communicate in Tamil, right? So whenever talking to your college faculty, you'll communicate in English, right? So you will know how to communicate with your friends, how to communicate to your parents, and how to communicate with your faculty. So there are some rules to be followed, right? So if you go communicate to your parents with in English language, will they understand? No, right? So the rule here is you have to communicate in Tamil. Okay. So similarly, these agents also have some rules to be followed when the communication happens. Okay. Now we'll see three different communications. One is peer-to-peer communication, messaging. Like agents talk directly. For example, Bluetooth, sharing phones or hotspot. If you have no internet at that time, what you'll do? You'll ask for the hotspot to your friend. So sharing that in a direct way. You'll go directly ask your friend, please turn on your hotspot. I'll just connect to that. Right. So will you do some communication in between? No. You'll directly go to your friend and ask. So that is how this agent talk directly to each other. Okay. And direct communication, no the third person will be there, no third person will be there in between, like a third, like no boss agent, no agent will behave like a boss. For example, so at a junction there are a traffic signals. So along with the car, bike also should follow the rule. Along with the bike, the lorry also should follow the rules. So everybody will observe each other. Like everybody will follow each other and observe each other. Then they will adjust the speed, just because to avoid some accidents and all. So to avoid that, everybody adjust their speed by observing each other. So whenever whenever you're going on a highway, sometimes you will see some damaged roads in between. So you will be observing. One second. Okay. Sorry guys, I just got a call. Okay. So here, no traffic police officer will tell everybody like every second. So at that moment, no need of traffic police to be there just to guide you every second. That is not. So that is not mandatory. Traffic police here is not mandatory. Okay. So that is why we follow each other. We come. What it is called, like, you will be observing the other people. Similarly here also, the agent observe each other and work. And the third one is decentralized system. So here, if you have 5 different agents, so this decentralized system is nothing but each agent thinks independently, works independently. Okay, like every agent will have its own independent goal to be reached. By end of the day, they will be clubbing together and will be completing. But for now, every agent will have different independent goals. In every agent thinks independently. Okay. That is called decentralized system. So this agent to agent communication makes system faster to work, scalable and flexible. For multi-agent collaboration, this is very helpful to complete the task. Clear? Is it clear, guys? A to A protocol. Okay. Now we'll see the key features. Key features of A to A protocol. Like how to, why do we need A to A? And because why we need this A to A? Because coordination to scale. The coordination is very important to understand. These key features help us how the coordination is happening. Okay, lightweight. The first key feature we'll see, lightweight message exchange. That means messages are small. Okay, messages are small, the lightweight, small messages and faster messages. So messages are small and fast. For example, SMS or email. So SMS, like quick updates. Fatafat you can give the updates, like small updates, quick updates can happen in SMS. And emails. Emails, you will have a huge content in it and fast. You can send it immediately. Like when you click button send, it will send. That's it. but the content will be heavy in that email. Like agents use SMS style of communication, like quick and short and quick. Next feature is asynchronous communication. So agents don't wait for the replies. So agent will not wait for the reply, whatever it is expecting. It will not wait for any reply. It will just send the message and leave. Okay. For example, you send a mail and continue working. You'll not sit and wait for the reply from your manager or from your teammate. Okay. You'll send the mail. You'll put all your details, what you have to mention in that mail, and leave. You no need to sit idle and wait for the reply. Similarly, here also, agent will send some responses, some details, and will wait. It will not wait for the responses. And the third key feature is improved flexibility and autonomy. Improved flexibility and autonomy is like each agent decides when to respond, how to respond. Okay. It should know how to respond to other agent and when to respond to the agent. So according to that only it will behave. The agents will behave. So these are the three key features of agent to agent protocol. Okay. So hope you understood. Do you have any queries, guys? What's happening in the Q&A section? CS Ramana's College, Muthulakshmi. What does it mean? Yeah. Okay. Is it clear, guys? A to A protocol, the key features, and how this A to A protocol works. Now we'll see the coordination multi-agent systems. What does it mean? So coordination, when you have a proper coordination, you will avoid duplicate works, right? Duplicate works will be get avoided, and if you have any conflicts, that will be avoided. You can avoid duplicates, conflicts, resource clashes in between. So this coordination in multi-agent system required when tasks depend on each other. When the task is depending on each other, at that time this coordination is very important. Okay. Like miscommunication or any duplicate work, double work. So if agent is working on the same work, two different agents are working on the same work, at that time duplication happens and time waste happens, everything happens. So you will not complete your task on time and duplicates happen, and some agent has to work again from the beginning for the other task. So if you have a proper coordination, all this can be avoided. For example, there is a construction site. Okay, electricians wait for the plumber. Painter waits for the wall completion. So here, without any coordination, everybody is waiting, right? So here, electrician is waiting for the plumber. Painter is waiting for the wall completion. So why this waiting happening? because they don't have proper communication. If they have proper communication, once the work like wall is completed, if he inform to the painter, he'll come and paint. Once the plumber work is completed, he will be informing to the electrician and he'll work on the electrician work. But if they don't have proper communication, what happened here? Everybody is waiting and the work is pending. So similarly here also, if they don't have proper coordination, you may face lot of conflicts. Okay. Distributed planning. Instead of one agent planning everything, planning is shared. The word itself telling distributed planning. One plan, like you're distributing the responsibilities. Responsibilities are shared to multiple agents to work on the task. Each agent plans its own part at the time. So for example, if you're working on a group project, so one student will work on the research part. So he will set one path. So he'll think like he'll be going through some research papers, he'll be going through some articles, some websites. So he will build his own path. So one works on the code. So he will have its own path. And one prepares the PPT for the demonstration thing, like for presentations thing. He will have one goal and he will have his own path. So when the work is get divided, when the work is get separated, they will have their own path, their own goal. End of the thing is completing the task together. All the plans are combined and the goal is achieved successfully. Okay. All plans together is like final submission of your goal. For example, as we are talking about the project, so we will like we have planned each student will work on one thing. One is on the research, one on codes, one on PPTs, one on the back end, one front end, everything. So all together, all plans together is your final submission of your project. Okay, that is how you distribute your planning for the task. Okay, responsibilities are shared, the planning happen just to achieve the goal. So these are very simple topics, guys, to understand. The title itself is telling everything. Distributed plan. The title itself telling everything. What does it mean? What is distributed planning? What it actually do? Everything is the title itself is telling. Okay. Hope you are understanding the session. Is it clear, guys? Can I get some response? Okay. Okay, Tulsi. Thanks for responding. Now we'll see leader election. What did you understand, guys? It's very clear. The word itself telling. Leader election. What does it mean? If you see the image also, you'll understand. What did you understand? Leader election. I'll see how many responses I'll be getting for this question. What did you understand by the title leader election? Nobody? Nobody understood what does it mean, leader election? Selecting, there is a break in task like data missing. How? Huh? I didn't get you, Rajesh. What you're telling? And Kavita, about this non-Moodle one IDs, please do contact your faculty. Leader election is like your like one agent become a leader here, who assign the task, who take care of everything, who takes care like all the task, all the responsibilities, everything is taken by one agent as a leader. That is what leader election is. And resolve all the conflicts if you face in between, and if some communication miscommunication happens, so that the leader take cares. Okay, so in your projects also, when you are assigned for a project and you are a team of three, so among three, one will be the leader who communicates you, who assign the work, and who distributes the work, everything. So they'll be elected as a, they'll be behave like a leader, they'll be taking care everything, right? Similarly here also, election, like one agent is selected as a coordinator where everything happens, assign the task, solve the errors, solve some disturbances between the agents and all. Okay, this is very useful in dynamic environments where the task has to be done quickly. Okay, that is about leader election. It's very simple, guys. Okay. Now we'll see the next topic. Hope this leader election is clear. Now, voting mechanisms. So agents vote on decisions like majority votes, and majority wins, right? When wherever you see, in whatever situations you see, everywhere we see for the majority. Okay, to select particular action or to select particular decisions, we'll go with the majority. Okay, for example, if we have two different decisions to be taken, we have two decisions in hand, so you are getting confused which decision should be selected, which action should be selected. At that time you'll go with the voting, and here majority wins. Every time we'll be go with the majority, as everybody will think in a different perspectives. So if majority is telling to select decision A, definitely we'll be going with the majority only. Similarly here also, so whenever the agent ask for the vote to select particular action or a decision, so they will go by the majority votes used. Okay, this is this majority mechanism is useful when agents have equal authority. Okay, agents have equal authority. If you are not listening to the to all the agents and you are just following your friend's gang, like only few people, that means you are not giving equal priority to other agents. Okay, so similarly, whenever you are having some elections in your college, okay, some president kind of thing, like event president or many type of elections will be happen in your colleges, right? At that time, you people will go with the majority. So if you only support your friends, at the time you're not giving priority, or you're not seeing other people in a equally. Okay, similarly here also. So maintaining that equality, equal authority for all the agents, here the votings and the selections of the majority happens. Okay, collective decision, taking a collective decision is called voting mechanisms. Okay, now blackboard systems. So blackboard systems is like shared memory space, sharing a memory space or a knowledge space, whatever. Agents read and write the information, where agents read and write the information. No direct messages needed here. Okay. So here the knowledge is being shared. One agent comes and writes some ideas, and the other agent comes and write the ideas, the other idea. So this is how the communication happen, like blackboard systems, where every agent can put their own ideas in there in that blackboard, so that others can see and refer. For example, hospital patient file. So in a hospital, every patient will have their own files. Okay. So what uh, doctor updates some diagnosis related file papers in that, and nurse come and read those diagnosis papers, what is put in by doctor. Everything will be read by nurse. And labs, what happens, all the lab reports are put in that file by lab assistant. Okay, similarly here also, every agent comes and put their ideas, read their ideas and write everything, all the information on in the blackboard system, so that everyone can be share their ideas. It's kind of a sharing ideas in the system. Okay, at one place, sharing an idea at one place. It's kind of a hub. Okay, clear? Lang chain for multi-agent workflows. So what does it mean? LangGraph multi-agent workflows. What did you understand, guys, about LangGraph for multi-agent? That means, so we know that agents communicate. Okay, agents communicate through direct messages or in many ways. Agents get communicated. But how do we control the complex agent when we have a complex agent interaction without any conflicts in between? How do you communicate? How do you control it? So that is where this land graph comes. Okay, using this land graph only, we will control the complex agent interactions. Okay, so Hugging Face la project Panama. Tomorrow, Jasmine, tomorrow you will be having a practical session where you can work. Okay, We'll show you how to work. Already 2 sessions are done. So tomorrow will be the third practical session. You'll be learning. Okay. Yeah. So the core idea, the core goal of this LangGraph is like representing agent workflows as a graph. Okay. Representing the agent workflows in a form of graph. Like nodes and edges kind of thing. Like nodes represent agents, and the agents are an actions. Edges like a transitions between the steps, like what kind of transition happening, what kind of things happening between the steps. So bottom of the screen you can see stateful agent graphs, nodes and edges, branching and loops, and memory and support. So we'll talk about stateful agent graphs. Agents remember what happened before. Okay, agent remembers what happened before, like what data is being shared before, how we have been operated, everything. So everything explained in stateful agent graphs, like online exam. So for example, you have attending an online exam. First, you will log in, you will attempting the exam, you will submit the exam, and then the result. So this is a workflow. Will you get the result first? Or will you directly submit your exam without attempting? No, right? So there will be one process to be followed. First is login, second is attempt, third is submit, and then result. The system remembers your state. So the system will remember your state clearly. How did you work? How did you start your exam? It is about stateful agent graphs and nodes and edges. Like each agent action is a node. So every agent, for example, if you have 4 different agents, every agent will have its own action. So that means we will have 4 agents, 4 actions, which is called as a 4 nodes. Clear? Like each step is a node here. Each step is a node. You are understanding? Yes. Okay. Next, we'll see branching and loops. So every agent takes different path. So if every agent takes the same path, it becomes again a duplicate work. So for example, if you are generating some presentations, you can't go to the Google as a research agent. Okay, there are 2 different agents. One is research agent and one agent is working on the presentations. So both can't go to Google, or both can't go to presentation slides. So one has to go to research, like for web sources like Google and all, and one has to come to the presentation one. If both go to the same thing, then the duplication happen. So agents can take different paths, different loops. They can work on different loops. For example, if whenever you're doing some online payments, if payment fails, what you'll do? You'll retry it. Okay. Even though if you retry, it doesn't work, then you will notify. You'll be getting one notification telling that your payment is failed, or your payment has has been delayed or declined, all these things will be, so you will be getting some notifications. So it will, this agent will notify to the human telling that payment is failed. If payment is success, and then the next step, right, it will again, you will be getting one notification telling the payment is success and you can go for the next step. So this is how the branching happens. Okay, every agent can choose its own path, supports the logic and iterations part. And memory support, that means agent remember the context. For example, if there are 20 different steps, agent will remember it. Agent will remember the context across 20 steps. Also 20 different steps, what happened in 15th step, what happened in 18th step, what happened in 4th step, everything will be stored in a memory support, in a memory, which can be helped for future, for whenever you face any difficulties, same difficulties, you can just follow it. So this lang chain brings structure and control to multi-agent system. All the controls and the structures are bought by lang chain graph. Sorry, LangGraph. It's not a chain. LangGraph, where all the multi-agents are controlled. Okay, in a proper collaborative way. Clear? Yes. Why there is no response, guys? Are you in the session? Okay. Kavi Priya, if you have submitted your NM ID wrong, contact your faculty. Okay. Now we'll see the next topic, task allocation and scalability. Like, assign task to a right agent is very important. If you assign a developer to work on the presentations, or the presentation agent to work on the developer, you can't do that. So if you do that, your task get collapsed, right? Assigning task to a right person, balancing the workload across the agents, and easy to add and easy to remove agent. So the system should support easy adding and easy removing the agents. Okay. For example, if you have more traffic, you'll try to go in other route. Okay. If you have less traffic, you'll go. So you have to be in a right path. Whenever you are doing any task, any kind of task is done by the agent, the work assigning task to a right agent is very important, and maintaining the balance between the agents is also very important to prevent the workload, to overload the overload the work for one single agent. You can't give multiple works to one single agent. So he can't, that particular agent can't manage everything all at a time, right? Instead, you can give right agent a right task. Okay, so task allocation is very important to maintain the scalability between the task and the agent. So if you want your task in a good way, you have to maintain the scalability without any loss or without any conflicts between. If you give a task to a proper agent, definitely you will not face any kind of conflicts between. Okay. Cooperation mechanism. Cooperation mechanisms like shared goals, negotiation, and conflict resolutions and all. Like shared goal initiatives like agents align actions toward a common objective. End of the day, how many agents work? So for example, if 5 agents are working on one single project, so by end of the task, the main goal of those 5 agents is to reach that particular goal. Okay. So even though you are working on different goals, the main goal will be reaching your task, reaching your goal, completing your task is your main thing. And negotiation and communication, the coordination through agents are very important. The cooperation system should be very good. The communication between the agents, if it is not good, you will have some conflicts to be faced. So to resolve that conflicts also, we will have some strategies to be followed. Okay, of handling the rules and the regulations. If agent is following all the rules, you will not have any kind of conflicts. Uh, as we already learned in before slides about the format. Okay, agent communication language format, message format, if that is followed by every agent, you will not face any kind of conflicts between the task, right? At the time the cooperation also will be good and you will reach the goal successfully. So cooperation is very efficient, guys. It's very important. And coordinated between multi-agent behavior is also very important. Coordination, if coordination is not there, definitely you will face a lot of issues in between. So cooperation and coordinations are very important in these multi-agent systems. So that is about the things like how you actually work with Lang graphs and multi-agent system. How do you allocate the task and how you maintain the scalability of the task? Blackboard systems, mechanism of voting, selecting the leaders of your task, and how do you distribute the plan? So to reach your goal, how do you distribute your plan to your team? Coordination between them, the language you maintain, the structure you maintain. So hope all these topics are very clear to you. And these are very simple topics, guys. It doesn't take much time. So much time is not required actually. If you just go with the title, it's very clear. It's not a big deal if you understand clearly the title. So did you understand? Do you have any queries? So somebody asked a question. Rajesh, ma'am, what kind of machine learning algorithms used for memory allocation? So we commonly use reinforcement learning, supervised learning like decision trees and neural networks. For a unsupervised learning, we will use like clustering and all to predict and optimize the memory. Okay, optimize the memory usage properly. We use all these things. Reinforcement, decision tree, neural networks, clustering, all this you can use. Okay. Clear, Rajesh? And the next question is by Tulsi. Any risk and challenges in task management? Yeah, definitely you will have a risk, some common risk and challenges like poor resources, resource conflicts, and if you have some communication gaps, at the time the risk and challenges has to be faced, right? And if you don't monitor the task properly, so workload balancing, if you don't have all these things, you will face a lot of issues. Okay, Uttara Devi, uh, please contact your faculty for all these things to solve your NMID. Okay, now any more questions about the session? Any topic you want me to repeat or anything to be asked? So tomorrow's session will be a practical session, guys. So you will be learning another task tomorrow. Along with that, all the Salesforce agent, champion, agent, Blazor, all these queries are solved in tomorrow's session. So please be present in tomorrow's session. Okay? Clear? Any more doubts? Okay, Sandhya, about this Agent Blazer Championship, you can ask tomorrow. So, so related to this Agent Blazer Champion and Agent Salesforce thing, everything will be solved tomorrow, guys. So the tomorrow session, related team will be joining. So whatever queries you have related to Agent Blazer Champion, you can post it in tomorrow's session. Okay. Along with that, you will have a practical session tomorrow. Okay. Yeah. Any more questions related to the session? If you have any queries related to the session, you can ask. Ma'am, did API used for communication among the agents? Yes. Yes, Rajesh. One second. Yeah. Yes, Rajesh. APIs are used for communication among the agents, like for allowing data exchange, or some sending some request, or sharing the task. For the coordination actions, we need APIs, right? So APIs are used for communication among the agents. Okay. And Vaishali, what I am telling is, I was telling, like, if you have any queries related to the session of today's session, you can ask. So if you have any queries related to non-Moodle ID, go to your faculty and ask. Okay. Any queries related to Agent Blazer Champion or Salesforce related queries, ask your queries tomorrow. Okay. Team will be there. So in 1 hour session, last half an hour will be your query session, where you can ask all your queries related to that. Okay. And first half an hour will be your practical session. Clear? Can you place the previous slide? This one, coordination mechanisms. Yeah, the non-Moodle one about the ID, Vaishali. About the portal, non-Moodle one portal. Yeah, you can ask the before one. This task allocation scalability. What is the doubt, Vaishali, about the portal? SEM 3 results. Okay. Okay, we'll just ask a team and we'll let you know, Vaishali. Okay. Yeah. Any more questions? No more questions, ma'am. Okay. About Devendran, about Agent Force related, please ask the query tomorrow. In tomorrow's session, the team related to that will join in tomorrow's session, 2 to 3 p.m. So please join and ask. Okay. Can you repeat the session for practical, ma'am? So Vaishali, so tomorrow will be the practical session, guys. It's 2 to 3 p.m. where you'll be working on Hugging Face. Like Venkatesh sir will tell you about the practical session. He will be handling tomorrow's session. Along with that, Salesforce team also will join. If you have any queries related to Agent Force and all, you can ask the queries to him. Okay. So please present in tomorrow's session. Please be present so that you can solve your queries. So Rajesh is asking, ma'am, in parallel process, is there a factor network traffic affect the data? Yes, in parallel processing, network traffic can significantly affect the data loading because congestion happens, latency, bandwidth, the limits can slow the data transfer. So due to this, the data transfer becomes slow and it causes the delays and the imbalance, right? Imbalance between the parallel task. Okay. It will affect the data loading part. The delays happen. Okay, guys. If you don't have any queries, we'll end up the session. If you have queries, you can ask or we'll end up the session in 2 minutes. Okay. Okay, guys. Hope you don't have any questions. Sure, Vaishali. Yeah. So please do join tomorrow's practical session from 2 p.m. to 3 p.m. to solve all your practical related questions or any agent force related questions. Please do join tomorrow's session. And ending up the session, guys, now. Nandri for joining the session. Bye bye. See you in next session.